guys, welcome to Empowering and welcome back to Anatomy 101. In this video, we're going to discuss the tissues, locations, and functions. This is a very exciting and interesting topic because we're going to discuss things like tendons, bones, blood, lymphatic tissue, all kinds of things. So we have a video jam-packed with information, so let's get right into it. Types of connective tissue, locations, and functions. The classification of connective tissue depends, as mentioned before, on the structural characteristics and functions. Now we are going to go over the connective tissue locations and functions, starting with mesenchyme. Mesenchyme is a primitive connective tissue derived from mesoderm that contains small spindle-shaped cells of relatively uniform appearance. The extracellular matrix is composed by reticular, fine, and sparse collagen fibers. It is primarily found in the embryo. Embryonic mesenchyme gives rise to the various connective tissues of the body. Mucous connective tissue. This connective tissue contains spindle-shaped cells widely separated, which appear like fibroblasts. Its ground substance, also called as Wharton's jelly, also consists of specialized, almost gelatin-like extracellular matrix, which occupies large intracellular spaces located between thin, wispy collagen fibers. Loose connective tissue. This connective tissue is composed by loosely arranged fibers and abundant cells of various types. It has thin and relatively sparse collagen fibers. Its ground substance is abundant, which occupies more volume than the fibers do. It has a viscous, gel-like consistency and plays an important role in the diffusion of oxygen, nutrients, carbon dioxide, and metabolic waste from and to capillaries. It is primarily located beneath the epithelia that covers the body surface and lines the internal surface of the body. It is also associated with epithelium of glands and surrounds the smallest blood vessels. Dense, irregular connective tissue. This connective tissue is characterized by having a few cells and abundant fibers. Cells are sparse and they are usually fibroblasts. The fibers are mainly collagen. The ground substance is also relatively scarce. This tissue receives its name because the collagen fibers are arranged in bundles oriented in various directions. Due to this type of arrangement and the abundance in fibers, dense, irregular connective tissue provides significant strength and can withstand stresses on organs or structures. In the case of hollow organs, fibers are arranged in varying planes, which allows the organ to resist excessive stretching and distension. Dense, regular connective tissue. This connective tissue is characterized by ordered and densely packed array of fibers and cells. Fibers are abundant and there is little ground substance. Fibers are arranged in parallel array and are densely packed, which provides maximum strength. Cells are packed and aligned between the fibers bundles. This is located in and is the main functional component of tendons, ligaments, and aponeurosis. And in each, the arrangement of fibers and cells vary, as described here. Tendons. In tendons, collagen fibers are arranged in parallel bundles. Situated between the bundles are rows of fibroblasts, which are also called tendinocytes. Tendinocytes are surrounded by specialized extracellular matrix that separates them from the collagen fibrils. Tendons serve as structures which join muscles to bones. Ligaments. In this type of structure, fibers are less regularly arranged than those of tendons. Also, some ligaments contain more elastin fibers than collagen fibers. Ligaments serve as structures which join bones to bones. Aponeurosis. In this type of structure, fibers are arranged in multiple layers, instead of lying in parallel arrays. The bundles of collagen fibers in one layer tend to be arranged at a 90-degree angle to those in the neighboring layers. Aponeurosis serves as structures which join muscle to bones or other muscles. Cartilage. Cartilage is a form of avascular connective tissue composed of chondrocytes and a solid and firm extracellular matrix, which occupies more than 95% of the cartilage volume. The chondrocytes are sparse and they produce and maintain the matrix. The matrix is constituted with glycosaminoglycans and collagen fibers. There are three types of cartilage. Hyaline cartilage, which is a cartilage that is characterized by matrix containing type 2 collagen fibers, GAGs, protoglycans, and multi-adhesive glycoproteins. This type of cartilage resists compression, provides cushioning for smooth and low surfacing joints, supports the respiratory system, and forms the foundation for the development of the fetal skeleton and further endochondral bone formation and bone growth. Elastic cartilage. This is characterized by elastic fibers and elastic laminae in addition to the matrix material of the hyaline cartilage. This type of cartilage provides flexible support. Fibrocartilage. This cartilage is characterized by an abundant type 1 collagen fibers as the matrix material of hyaline cartilage. This type of cartilage resists deformation under stress. Bone. Bone is a connective tissue characterized by a mineralized extracellular matrix composed by hydroxyapatite crystals. This feature produces an extremely hard tissue capable of providing support and protection, and also allows bones to serve as storage sites for calcium and phosphate. Bone matrix also contains types of collagen along with protoglycan, multi-adhesive glycoproteins, bone-specific vitamin K dependent proteins, growth factors, and cytokines. The main type of cells in bone tissue are osteocytes, osteoprogenitor cells, osteoblast, bone lining cells, and osteoclast. Osteoblasts are responsible for secreting the extracellular matrix of the bone. Once the cell is surrounded with the secreted matrix, it is referred to as an osteocyte. Osteoclasts are responsible for bone reabsorption and thus reorganization of the bone structure. Adipose tissue. Adipose tissue is formed by adipocytes or fat cells. As mentioned before, this type of cell accumulates fat for their cytoplasm in the form of triglycerides. Triglycerides serve as a dynamic energy storage that can be rapidly released for use when it is needed. Adipocytes also produce a variety of paracrine and endocrine hormones, which participate in the regulation of energy metabolism. Two types of adipose tissue exist. White unipolar adipose tissue. This is the predominant type in adult humans. Its function is storage of energy, insulation, and cushioning of vital organs, as well as secretion of hormones. Some of these hormones are leptin, angiotensinogen, adiponectin, and resistin. Brown multipolar adipose tissue, presented in humans during fetal life and in some locations in adult humans, such as around the kidneys, adrenal glands, large vessels in the neck and back, and the mediastinum. It contains numerous fat droplets. Metabolism of lipid in brown adipose tissue generates heat in a process known as thermogenesis, which helps offset the extensive heat loss and avoid hypothermia. Blood. Blood is a fluid connective tissue that circulates throughout the cardiovascular system. Like other connective tissues, blood consists of cells and an extracellular matrix. The extracellular fluid is called plasma, which contains proteins, gases, electrolytes, nutrients, regulatory substances, and waste materials. Plasma proteins consist primarily of albumin, globulins, and fibrogen. Cells present in the blood are erythrocytes, which are called hemoglobin, a protein specialized for the transport of oxygen and carbon dioxide. Leukocytes that work as a defense in healing cells, and thrombocytes, which participate in blood clot formation. Blood's main function is to transport substances from one place to the other. This includes delivery of nutrients and oxygen to cells. It also includes the transportation of waste and carbon dioxide away from cells. It delivers hormones and other regulatory substances from cells and tissues. It also assists in the maintenance of homeostasis by acting as a buffer and participating in the coagulation and thermoregulation and transport of humoral agents and cells of the immune system that protect the body from pathogenic agents, foreign proteins, and transformed cells, for example, cancer cells. Hemopoietic tissue. This is a tissue in which new blood cells are formed through a process called hematopoiesis. Hematopoiesis includes erythropoiesis, or the formation of red blood cells, leukopoiesis, or the formation of white blood cells, and thrombopoiesis, or the formation of platelets. All of these processes occur in red bone marrow. Lymphatic tissue. Lymphatic tissue are parts of the lymphatic system, and they serve as sites where lymphocytes proliferate, differentiate, and mature. Lymphatic tissues include lymphatic vessels, diffuse lymphatic tissue, and lymphatic nodes. Lymphatic tissue can also be found in some organs, such as the thymus, spleen, and tonsils. Alright guys, I really hope you liked that video going over the tissues, locations, and functions. Make sure you stay tuned because in the next video we're going to go over the integumentary system, or the skin. This next topic is so interesting because it is an organ that we take for granted all the time. What's really interesting about the skin is the effect it has on every single organ system, which we will be discussing soon. Also, if you're a student taking anatomy and physiology or you're about to take anatomy and physiology, this is a class that you really need to know how to study for because it is so much information, it's ridiculous. So I do have a program that I uploaded to the membership part of this channel where I show you how I went from basically failing anatomy to acing it. And I've helped thousands of other students do it also. This program's actually been around for about 6 years. I did redo it and I've made it a lot easier to get for the very small price of $5. That is a monthly charge, but you can cancel at any time. However, as long as you're able to continue, it'll help me create more amazing content. Alright guys, stay tuned and I cannot wait to see you in the next video. Love you. Bye.